Welcome back, Night Owls. This is Dr. Nighttime, and tonight we're going over how to estimate natural logarithms, pen and paper. These estimates will be accurate to about 0.01. They'll be off by like 0.01, 0.02, something like that. The one I have here actually is off by more like 0.03 because I attempt to estimate a really big number, but does about as well as you could expect, or hopefully better than you might expect to be able to estimate natural logarithms, pen and paper in a reasonable amount of time. It starts with a little bit of memorization. You need to memorize the values of a couple specific natural logs. First is natural log of 10. That's approximately 2.30. Then there's natural log of 3. That's about 1.10, which makes sense because E is like 2.7 something, so 3 is a little more than E. Makes sense that it would be about 1.10. And then natural log of 2 is approximately 0.69. Well, your typical teenager should be able to come up with a mnemonic for that. Anyway, we also want to use a couple specific properties of natural logarithms. First, there's that natural logarithm of a times b equals natural log of a plus natural log of b. This helps when we're taking natural logs of really big numbers. We can just move over the decimal places, decimal points however many places we need by just dividing out enough tens and thus subtracting off 2.30 enough times. And finally, well, we know from calculus that the derivative of the natural log graph is just 1 over x. This means that if we know natural log of x, then natural log of x plus a little bit equals the natural log of x that we know plus that little bit over x. Right? That's just first order Taylor series approximations or linear approximations and just thinking about the slope of the natural log graph and seeing what that does. And so let's put this all into action and see what we can get out of this. Let's approximate the natural log of the current world population, which when I most recently checked worldometers, it was approximately 7,840,401,450. All right. Well, first thing we'll want to do is get this almost in scientific notation, right? We'll want to think of it as 7.840 whatever times 10 to the 9th. So that's going to be natural log of 10 times 9 plus natural log of 7.840 whatever, right? I'm using that natural log of a product, in this case 7.84 times a billion, equals natural log of a billion plus natural log of 7.84 whatever. And that natural log of a billion is just natural log of 10 times 10 to 9 times. So that means I can just add up ln 10 plus ln 10, blah, 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 9 times. Now I need to figure out what the natural log of this 7.84 whatever is. Well, I try to find a good anchor point. And fortunately, knowing 2, 3, and 10, I can get good anchor points all throughout the range from 1 to 10. Right? Obviously, ln of 1 is 0. Ln of 2 we have. You can even do ln of 3 halves and 4 thirds, right? 4 thirds from just ln 2 plus ln 2 minus ln 3. We've got ln 3, ln 4, right? ln 4 is just ln 2 plus ln 2. ln 5 is ln 10 minus ln 2. ln 6 is ln 2 plus ln 3. ln 7 you can't hit exactly. There's ln 8, which is ln 2 plus ln 2 plus ln 2. If you wanted to get more interpolation between there, you could get ln of 6 and 2 thirds, which is 20 over 3, so ln 2 plus ln 10 minus ln 3, and ln 7 and a half, which is ln 3 plus ln 10 minus ln 2 minus ln 2. And then ln 9 is just ln 3 plus ln 3. So you get your breakpoints wherever you need to. For this one, I chose 8 as my breakpoint, right? And I want to anchor it around 8. Then I know that the ln function around 8 has slope 1/8, so I say it's going to be 1/8. So I'm going to subtract off 1/8 times. I'm just going to round this to 1.60 and ignore all this extra stuff afterward because I really can't get more than 2 decimal places accuracy out of this anyway. But this will get you 3 times ln 2 minus 1/8 of 0.160. knowing what ln2 and ln10 are, I just say, okay, it's going to be ln10, that's 2.30 times 9, all right, plus 3 times 0.69, minus 1/8 of 0.160, and with some simple pen and paper arithmetic, we get 22.75. Compared to the actual result on the calculator, it's 22.78. So, not a perfect approximation, but still probably better than you might have thought you could do pen and paper for natural logs. Yeah. And so in the unlikely event that you ever find yourself needing to just estimate a natural log pen and paper, here's how you can do it. If you like that and want to arrange private lessons, click the link in the description. And until next time, this is Dr. Nighttime wishing you a good night.